Sounds good to
Yeah,
me.
this dude has done like a ton of problems in the past 4 months. And then,
Yeah, fair. Yeah, I'll raise your volume. Can you?
So what is the topic? Like, okay, if I don't know if it's too late to request, but I prefer some like graph practice. It's fine if your problems aren't graph related.
Oh yeah, I already chose the questions, and I'm not sure I
Alright.
can find some in like 2 seconds and like be a good like interviewer with them.
Yeah, it's fine. It's all good.
But yeah, if ever you come back, I'll keep that in mind. But basically, what I did is like I tried to focus on more like a data structure design question because I feel like if I
Hmm.
gave you an algo, you probably already saw it.
Yeah, that's true.
So I
Yeah,
tried.
I mean, I'm down with that. Yeah,
Okay,
I
okay,
need some practice on like object design stuff too. So,
yeah, yeah. So I focus my attention on that, and hopefully you'll like it. Yeah, okay. So we need to set up things right. I forgot. So we just need a REPL. And chat, is the sound okay now? So REPL it. I'll hide the link so people don't just join during the interview and start typing shit. So Python, yeah, of course.
yeah.
All right, and create REPL. Just 1 second. Okay. So I'll ping you on Discord. So you got the link?
Yeah, I need to log on though to REPL.
All right. Take your time. You have 1 minute. No hurry. I'm just gonna chill.
Wait, what? Okay, let me just try to join this. Oh. All right. Let me know if you can see me typing or not.
Yeah, looks good.
Okay, cool.
So we are ready to begin. Get your popcorn, guys, because it's gonna be a good one.
All right, bet. Let's go.
Let's go. Okay. So drum rolls. The question today will be, well, at least the first part of the question. I think you saw that one already, but LRU Cache. Let's remove this crap here, and this crap here, and this crap here. So the question is, design and implement a data structure for least recently used cache. It should support the following operations: get and put. So you have get key that gets the value, and it will always be positive, the key, if the key exists in the cache. Otherwise, return -1. And the other function is put key and value. It sets or inserts the value if the key is not already present. When the cache reaches its capacity, it should invalidate the least recently used item before inserting a new item. The cache is initialized with a positive capacity. So don't need to worry about the time complexity right now, but here's an example of what the execution should look like. And I guess I can give you also like the header of the class. It should look like this.
Got you.
And that's pretty much the problem. Do you have any questions before you begin?
Let me just make sure I got the function signatures right. So let's do like def put. It's gonna be self, I guess, k key value, right?
Yeah.
And like def get is gonna be self key.
Yeah.
And this is it, right?
Yeah.
All right, cool. So, okay, so essentially what we need to do is, so I do know this problem.
Of course.
I will go through it, like just talking through my thought process though, because it's been a really long time since I've seen it. So,
okay, fair.
So essentially what we need to do is like, basically be able to have like three functionalities, right? We need to be able to get a key. We need to be able to put a new key value pair in, or like update the key value pair, like the value that the key corresponds to. And then the third functionality is that we need to somehow like keep an ordering of like what were the latest used keys, because when we reach the capacity, we need to get rid of the item that was least recently used, right?
Yeah.
So essentially, like if we think about this, right, what are some options that we have? If we do a list, we can the problem with the list is that if we like, let's say we get an item or a key. Okay, so let's say we have like a list, right, with all the keys or whatever, like the order they were used. Well, let's say we get like we get 4, right? In order to like reorder this 4 to say, okay, 4 was the most recently used, we're gonna need to take it out of the list and then put it at the front of the list, right?
Yeah.
And the problem with this is that it's O of n time, because there's no way to like with like array there's no way to like pop an element and put it at the end in constant time. So the typical data structure we use if we need to do stuff like that, like popping stuff from the middle of the list in constant time, is a doubly linked list. So essentially what I'm going to do is have a doubly linked list, and it's going to have each of the nodes in this doubly linked list is going to be a key. It's going to represent a key. And then we're going to have like a dictionary as well, pointing like the key of the dictionary is going to be the key of the key value pair, and then it's going to point to these nodes. So then we can essentially like rearrange everything in all of one time per operation.
Sounds good.
Okay, cool. So let me just write out like what I'm going to need, right? I'm going to need a node class for the doubly linked list. Let's see. I should have the key and the val in here. And basically, like the dictionary here is gonna have like let's have a self.cap. And my dic's gonna have like it's gonna be key to node, and the node is gonna contain the key and the value in it. So if I need to get the value, I'm just gonna go in the dictionary, go to the node, and get the value. Okay, so I need key val self.key, just key self.val. I also need a next and a prev for this thing. Okay, so what do I need for the doubly linked list, right? I need to store it in this LRU cache object. I need to have the head and the tail, because that's just what you need for the doubly linked list. So let's have self.head equals node. Yeah, let's do this. Okay, so now let's do like the operations, right? So just a bunch of linked list node manipulations now. So let's say we're putting, so what are the two options? When we're putting, either there is the key already exists or it doesn't exist, right? So if it doesn't exist, so if k not in self.dict, I need to make a new node, and then I need to insert it at the front. So let me think, like there's kind of two options, right? Either I can make the nodes closest to the head the most recent ones, or the nodes closest to the tail most recent ones. Let's see what like makes more intuitive sense to do. Let's see.
I don't think it matters as long as like you define it clearly. I think
Yeah.
they both have the same result.
I'm just thinking like to me was more intuitive, so I won't get it mixed up, you know.
Okay.
Yeah. So so let's make the stuff near the head the most recent. So let's say right here, run a node, right? Closer to head equals more recent. Okay. So let's have node equals node key val. Can I turn off this autocomplete? This shit is like,
I'm not sure.
I think there's an option in settings.
Code intelligence in settings.
Yeah, just turn it off. Okay, I turned it off. Okay. Okay, node equals node, and then I want to do let's make a helper function for inserting, right? So let's call this refresh, and what this does, let's call this node. This like puts node in the front next to head. So self.head.next.pre equals node. Node.pre equals self.head. Self.head.next. Let's do node. Next equals self.head.next. Let's see. So I'm attaching the head next prev to me, my prev to head, my next to head next, head's next to me. Okay. And then let's also have like a function for like deleting nodes. So like all I really have to do here is if it's not in dictionary, I just need to put it at the front, right? So I'm just gonna do self.refresh node. Okay, let's say it's in the dictionary already. Oh, I forgot one thing. Self.dic of k as equal to node, because I need to add this reference. Okay, otherwise node equals basically self.dic of k, right?
Yeah.
And then I just need to do self.rem. So like the node is currently at some position in the linked list. I need to take it out and put it at the front. So let's just remove it, just taking it out, and then let's just refresh it. And then let's do node.val equals b, right? So ahead. Because I'm updating it.
Yeah.
Updating the value.
Yeah.
Okay. Let's see. What else do I have to do? So, okay. So in the case it's already there, I get it. I remove it. I refresh it, and then I. Okay. In this case, like having a size variable. So I need to check if the size is too big now. Okay, so after this, like if self.size is greater than self.cap, right? That means like it has to have been one extra because I'm adding one at a time. All I need to do is just pop from the end. So let's just remove self.rem, like self.tail.prev. So that should get rid of the last one. And the size is if size is 0, it's totally fine. Like size won't be negative, right? I mean capacity won't be negative.
Yeah, it's always positive.
It doesn't make sense. Okay. Okay. So let's just assume that, like, I'll come back to this and check it later, right? But let's just do the get now. So the get is kind of similar. If k not in self.dic, I'm just going to return. What am I supposed to return? Was -1.
Yeah.
Okay. Otherwise, it's in the dictionary. What I need to do is like red equals self. Let's say node equals self.dic of k, right? Red equals node.val. Pretty much. Then let's just refresh this node basically. Is that it for this one? Okay, let me like walk through like an example or something. I probably missed something. Let's just take this example up here, right?
Yeah.
Let me make this bigger. All right. Okay, so I'm gonna like represent the nodes like this. Actually, let me walk through my code first, like in my head, and then I'll walk through an example.
Yeah,
Because I
take your
probably
time.
catch something. Yeah. So let's say we're putting, right? So def put. Okay, let me check these variables. Cap, size, dict, head, tail, head dot next tail, tail dot previous head. And this one should all be fine. This is what I need. Okay, so put if k not self dot dict, then in that case I need to make a new node because it's based. Oh, I did forget something. I need to delete this from the dictionary. Let me do this first. Like this, right? I need to take it out of the dictionary so that like next time I put it, I know that it's not there basically. Okay, so if k is not self.dict, then making a new node kv, I think is fine. Self.dict k is node, so I'm pointing it to there. I'm refreshing the node, so like I'm just putting it in front of the head, and then size plus equals 1, which makes sense because I'm adding a new one. Now in this case, it already exists. I'm gonna remove it, meaning like I just disconnect it from wherever it is right now, and then like join its two neighbors together. I need to refresh. Refresh meaning that I need to put it in the front next to the head, just like I did here. But I don't increment the size because the I'm not actually adding a new entry. Now, if the size is too big, that means that I was at capacity earlier, so I need to get rid of one now. Then I'm gonna delete self.dict. So this is gonna be the last, like the least recent, basically the least recent key that was interacted with. So I need to delete it, and then so I'm deleting this. Then I need to remove that node. Okay, so this seems fine.
So
And
I'm not
then,
sure, but maybe you have to decrement the size.
yeah, I do. You're right.
Like small detail doesn't really matter.
No, it matters. It matters.
Yeah,
I
it
should have
matters,
caught that. Yeah.
just
Okay.
pointing it out.
And then for get k, if k is non-self.dict, return -1. Right. Otherwise, node is this. Ret equals node.val. I need to return ret. And let's check my helper functions. I think this looks good, right? All I'm doing is getting rid of the node. Prev.next, node.next, next.prev, node.prev. So I don't actually do anything to the nodes pointers itself, but I don't think it matters because like whenever I remove, I either like don't care about the node anymore or I refresh it. And then when I refresh it, I like update the pointers, right? You can see that.
Yeah.
So I don't really have to update the nodes pointers itself here. Okay, refresh node, head.next.prev equals node. Node.prev equals head.next equals head.next. Head.next equals node. Yeah, so this is prev. Oh no, this is next. This looks good, right? I don't think I think I'm doing these in the correct order. It should work.
So let's say your linked list is empty. Do you like need to change the reference from the tail to the current node if you're adding a node?
Okay, so here's the thing, right? In the beginning, what is the head's next pointer?
It's the tail, right?
Yeah, so this is
right,
gonna be
okay.
tail.prev. So I don't need to do that, yeah.
Okay,
That's
cool.
why I use the doubly linked list. Like it's pretty convenient because if you link them in the beginning, you don't need any special cases for the empty list.
Okay, yeah, cool.
So should I walk through like an actual example now, or?
Yeah, I could like write some tests.
Oh, yeah, that makes sense.
While
Okay.
using the example is good enough.
Sure, why not? Okay. How does this initialize? LRU cache capacity 2. Here, let me just print this. I don't want to write print statements in front of everything. Like this should be good enough, right? Yeah. Oh yeah, this is Java. Okay, key error 1. And 970 input. So this wasn't actually in the dictionary properly. So do I actually update it properly? So it says 1, 2, oh no, I guess this one prints. This one prints. Okay, hold up. So this one works. I think this one, yeah, this one fails. So 4, 4, put 4, 4. If canon self.dict. So it's on line 70, which means it went to this case. If self.size greater than self.cap. So that, just give me a second. I'm gonna draw out what it actually looks like and see what this one was supposed to be.
Okay, okay.
Okay, so I put in 1. Then I put in 2, basically. Then I get 1, so 1 should get put back to the front, right? And then I put 3, so 3's here now. Then I get 2. Yeah, so it's trying to remove the right one, but it's just where I put 3, get 2, so 2 gets to the front. It tries to put 4, so 1 is the one that's supposed to be deleted, but for some reason my 1 is not in the dictionary. It says key error 1.
Mm-hmm.
You mind if I print out the dictionary whenever I put?
Yeah, if it helps you, it's fine.
Alright, let's see. Self.dict, make a new node. K equals node, refresh node. Okay, wait. Okay, I'm gonna get rid of this too. So, like, this doesn't look right. Like, why is the tail, why is 1 trying to get removed twice here? Right. Like, that doesn't seem right.
Mm-hmm.
Okay, so at this point here, okay, so let me draw this out again. The capacity is 2. So I'm putting 1 in, putting 2 in, getting 1, 2 gets put to the front. Putting 3 in, this point 2 should be removed. Right, so at this step here, 2 is removed, right? And then the thing should look like a 3 and then a 1. Do you agree with that?
Okay, so you put 1, then you put 2, so it's 2, 1. Then you get the 1, so the 1 is put in the front. Then you put the 3, so it's 3, 1, because the 2 is removed. Yeah, makes sense.
Yeah, so this one, at this point, it should be the, so I'm printing out what's removed, right? And for some reason, the 1 is getting removed the first time. So that makes me think that my get, I'm not refreshing properly because apparently it's removing this 1, and at this point, the 1 should be at the front already, right?
Yeah. So I think that usually you use the remove before refreshing, like in the put. When you just update the value, you do a rem and then a refresh, and then in the get you just do a refresh. So maybe there's some issue with that.
Oh. I think you. Let me think. Yeah, you might be right. If K and okay, so this is not the case. Node. I definitely do need to remove it first. So let's just do that. Yeah, I think you might be right. Let's see what happens now. Okay, now let's print the values. Yeah, I think that was it. So let's print red and print with 1, 2, 0, black 1. So this one is 1, right? And then get 2 is -1. That's expected. 4 should push out the 1 because this should be like.
Yeah,
Well, let's see, right?
the output is good according to the example.
Yeah, it seems right. Okay. Yeah.
So
I definitely. I just forgot to type this, I guess. But yeah, I definitely have to remove and refresh whenever I update the position.
yeah, so I think that pretty much concludes that problem. Like, you're pretty good, like knowing how to do everything, but of course you already saw it. But maybe like a small thing you could work on is like maybe naming your functions, because like the small bug you had right here, I think it's because at the beginning you call a function refresh, but in the end it was just inserting and not doing all the refresh procedure. So I think you like assumed that it would refresh everything, but like the definition changed while you were coding it. So maybe like make sure that you're naming according what the function is really doing, because now it's not really refreshing, right? It's just a normal insert. So like it forces you to always call remove and then refresh together, while in reality maybe the refresh function should do both the insertion and the removal before it. So maybe you could have a function like insert and a remove, and then have refresh that uses both. So you basically try to modularize your code more. So it's like small details you could improve on, but I think like in an interview setting, it's definitely like a good performance, I would say. Yeah, LRU Cache in less than, actually it's like in 20 minutes. I think we started at 5 minutes past the hour. So yeah, 20 minutes for this question is pretty good. So
like knowing that I like done the question before, I feel like I could like not messed up, but I mean, yeah,
it's like small
I feel like the problem is like because what is it, the reason I kind of split up is because you see over here I can't remove here, so I was thinking like maybe I should have named it like yeah, you're right, maybe naming it better would have prevented me from messing up there, so I'll watch out for that.
Yeah, like even if like you can't use all of it, maybe here, so you can't remove. So how do you I'm not sure how you refresh without removing it though. Oh, because it's not.
I mean,
you
refresh
just
like
okay.
in my mind is just like putting it in the front. Like that's what I thought like refresh is. So
okay.
I think it was more of a like me just forgetting to like going on autopilot here and thinking like, oh, it's the same thing, and then forgetting to type this line. I think that was what it was. Yeah.
Yeah. So gotta be careful with that. Naming is one of the hardest challenges in programming, and I think
for real.
Yeah, that's what they say. I think it's like a quote somebody intelligent said. I wouldn't know, but but yeah, your whole performance was good. I think you're a really great communicator on that aspect, and I'm really curious how you would perform on the next question. So I'm I'm skeptic that it's possible in like 30 minutes, but I just want to see how you managed to go through it. And I don't know if you already saw it, but the question I want to ask you is called LFU Cache. Have you heard it?
LFU Cache.
It's
I think
least frequently used cache.
Let me see if I've done it.
Well, don't look up the answer, please.
No, I won't. I'm just looking at my submissions.
Okay. But yeah, it's basically the same principle, but instead of removing the least recently used, you remove the least frequently used element from the cache. So are you down
Okay.
to attempt it live in front of an audience?
Yeah, I don't care. Yeah, we can do it.
All right.
Do you have the description or
Yeah, no, I'm
actually like can you just knock me the description because I feel like interviewers not gonna paste. I mean, like I feel like they'd expect you to like ask questions about it and stuff, right? Rather than giving like a blurb of text.
Yeah, that sounds fair. I've had the blurbs
Okay.
of text in my interview at Square at
Oh,
least.
really?
Yeah, they just
Okay.
pasted it and they read it for you. Even one guy was like, I don't feel like reading it. Like, just read it and like tell me when you're ready." Like
Okay.
the laziest job, just paste the text and like sit there and take notes. Sounds like a fun
I
job.
mean, let me just try though. Let me just try to like ask you questions
Okay,
about
okay,
it.
sounds cool. Okay, so
So
LFU cache.
essentially,
Sorry.
LFU cache.
Yeah. So
Okay, so essentially, like, are you gonna like talk it out, or
yeah,
am
I'm
I
gonna
gonna ask
read
you
the problem
questions?
statement, and then if you want
Okay,
me
I'm
to
down.
ask me questions without me even like describing the problem, like go
I
ahead.
have a general idea of like what it means. You want me to delete everything right now?
I think you'll need some of the logic because reuse some
Oh my
element.
god, is it a build on it? That's gonna be okay.
It's
Okay,
like you want, to be honest. Like if you think it's better to scrap everything and start from scratch,
no. If you think I should keep it, I'm gonna keep it. So, all
it's
right, let's
it's
go.
not my interview. Like
No,
yeah,
I'm gonna. If you think it's like a best for me to do so, I feel like I should keep it.
we'll see, we'll see. All right, so here's the question. So design and implement a data structure for least frequently used cache. It should support the following operations: get and put. So basically the same API as the LRU cache. So get the value will always be positive of the key, and if the key doesn't exist, return -1. And put key value, set or insert the value if the key is not already present. When the cache reaches its capacity, it should invalidate the least frequently used item before inserting a new item. So this is a small thing in our cache is you inserted the element before removing it. So you made a little overflow. So I don't think an interviewer would care that much about like the order of operation, but it's like a small pedantic detail, I'd say.
Mm.
Yeah, it's a small thing. So I wouldn't judge like the ability of a person based on that. So anyway, closing the parenthesis. So for the purpose of this problem, when there's a tie, so possibly there's two items that were used as frequently. So in that case, the least recently used key would be evicted. So note that the number of times an item is used is the number of calls to the get and put functions for that item since it was inserted. This number is set to 0 when the item is removed. So that is the question. I'm listening to whatever questions you could have about the problem, and I'm here to guide you if you ever need me.
Okay, got you. Okay, so just let me know if I got this correct, right? So it's gonna have the same API as LRU Cache.
Yeah.
The difference is that, okay, so instead of having like doing removal by which one was like most like least recently used, we're gonna remove the one that's least frequently used.
Mm-hmm.
So a use is like a update of a key or a get.
Yeah.
And then when we put in the like a new key, does that count as one? Or I guess it doesn't matter, huh? Yeah, it doesn't. It shouldn't matter.
Yeah, because everything's gonna be offset at the same pace, right?
Yeah. Okay. And then you said that if we have basically okay, so in the case that there's like a tie, we're taking least recently used.
Yeah, exactly.
Okay, so yeah, so I feel like gonna need to have like a mini LRU cache, like like a mini LRU cache or something for free. So like I think I have like a general idea for the how I'm gonna do the least frequently part. So let's say I have some nodes, right? Like these nodes are gonna have like a value representing how many times something like so this node is gonna contain all the stuff that was used 5 times. And this one's gonna be like all the ones that are used like 3 times. And then like so basically like in a node, I'm gonna have the count, and then I'm also gonna have the list of like key value pairs, I guess. But like the problem that comes in when you have to do like the tiebreaker, like so I'm just gonna talk assuming that we don't have to do this LRU tiebreaker thing. I will just like I'm gonna have a head here, right? And then I have a tail here. And then I'm gonna do like this like a bunch of this is all O1 operations where I move stuff in between these nodes. And if like the node is empty, I'm just gonna like delete it, right? Empty meaning there's no key value pairs. And then if I reach capacity, I'm just gonna get the one closest to the head and then just get rid of one of them, like arbitrarily. Does that make sense?
So let's say you would update a value, and like currently your LFU cache would have like 10 elements that have a frequency of 1, and you update one of them. Like what would be the complexity of updating it?
So like basically it'll be like this then, right? And this one node is gonna have like a bunch of key value pairs in it. And then I'm going to so it's O of 1 because I'm gonna make a new node with 2 in it. Okay, so the first thing I do actually is I have to check if the next node like is already a 2 frequency node. In this case, it's not because it's a tail. So I'm gonna make a new node. I'm gonna connect it, like I'm gonna do the inserting thing, like I did in LRU Cache, and then I'm going to like pop the get rid of the key value pair from within here, and then put it into here. So that's O of 1.
Yeah.
And then okay, so okay, that's like not even considering the LRU part though, because I basically need an LRU cache within each of these nodes, right? Like, because there's no real way around it, because each node is basically an LRU cache, and then so let me just try to like do the least frequently used part with like an arbitrary ordering of the LRU like within the nodes, and then if I have time, then I'll try to do the LRU part too.
Yeah, sounds fair.
Okay. Here, let me just calm this out for now. I'm assuming that's what you meant to keep it for, right? Because I kind of need it, but
yeah, it's
I'm
for
not doing
you,
that
really.
yet.
If
Okay,
there's
okay.
any code you can reuse, go ahead.
Right. It is kind of similar, but the nodes are different, right? The nodes are going to have the key value pairs in them, basically. So, okay, so let's have class node. So this is going to be like freak, right? Okay, so it's going to have a self.freak equals freak. Self dot what? I need to have like a dictionary, basically. Okay. And then let's do like a class LFU cache. Okay, so self.head. What do I need, right? So let's see. During my get, I need to know for each key which like frequency node it's in, basically. Or alternatively, I can like store the key value pairs in within like a dictionary in the LFU cache. Which one is better? Let's just keep it in the node. So okay, so let's have a self.dic equals this is gonna be key to like a node. What's it gonna do? Okay, and then okay, we have that. What else do I need? I need a head and a tail. So if okay, so let me go through this again, right? When I get the value, I'm gonna go into dic and see if it's in there, and then I'm just gonna go to the LFU node, and then look up in the LFU node.dic to get the value. And then what I'm gonna need to do then is that within the LFU node, I need to take out this key value entry. So I'm gonna do something like self.dict.remove k, and then I'm going to put it, and then I need to check if node.next I need to check if node.next is do I even need doubly linked in this case? Do I need to look backwards? I'm thinking I might not need the doubly linked for this one because
Well,
I only need to.
what do you do if there's no more entries for a certain frequency?
I need to remove it. Yeah, are you talking about like when one of these LFU nodes is empty?
Yeah.
I just get rid of it, right? And then point to the next one. But okay, I guess like it's definitely easier to have a prev just so I can look at the last one and then point it. So I'll just keep the prev, I guess. Yeah, or else I'd have to like, oh yeah, I definitely do need the previous, yeah, to remove. So you're right. So check the node.next dot freak is node.freak +1. If not, make a new node. Okay. And then I need to basically put kv into node.next dot. Okay. So I think this is along the right lines for. So this is get or get. Yeah, this is get. This is also put. It's very similar in the case that it's already in the dictionary. If it's not in the dictionary, what I need to do is like make an. Okay, so I'm gonna look at head. I'm gonna see if the node next to head, the LFU node next to head is a 1. If it's not, I need to make a new node. So it's like, but let me just focus on one thing at a time here.
Mm-hmm.
So subset head equals LFU node, subset tail equals LFU node. Okay, what else do I need here? Let me just start writing other functions. If I need anything, I'll just add it. So let's do def get. I think it makes more sense to write put first, actually. So let's just do. So for put, I need to, first of all, oh, excuse me, give me one, like 10 seconds.
Yeah, no problem.
Okay, I'm back.
Okay.
So let me just write out like what I need to do for put, right? So if k, okay, no, let me just write out get first. So I'm gonna follow what I wrote here. So first of all, I need to what is this? Self.dict.remove k. Oh, that's for the node. Okay, so let's say node equals self.dict of key. Well, if key not in self.dict, then return -1. Otherwise, it's in the dict, so I'm gonna get this node, right? And then I'm basically going to remove it. So node dot dict. Let's say ret equals node dot dict dot of key. So return value. And then I need to do del node dot dict of key. And then I need to now check the next node, right? So if node dot next dot freak is not equal to node dot freak +1, this means I need to make a new node. So let's see, should I make a helper function for making a new node? Because I think that's something I have to do in the other ones as well, right?
Yeah, I think it's a good idea. Yeah.
Yeah, so let's just do like get def like add after. Okay, so node. I need to say what I want to add after. How about node and like new freak or something? So node dot next. Okay, so new node equals LFU node of new freak. Node dot next dot pre equals new node dot new node dot next equals node dot next equals node next new node dot next equals node dot next new node dot next new node. Okay. Okay, so if node dot next dot freak is not equal to this, then I need to basically self to add after node. Yeah, so I'm adding after this one because my stuff's increasing. So node node dot freak plus 1. And then now I know I definitely know that the next node is gonna be freak plus 1. So let's just do node dot next dot dict of key equals val. And then just return red. Okay, so if key is not in the dict, return -1, right? Otherwise, I basically need to get the node, get the return value, because it has to exist. If this dict has it, then this dict also has it. The LFU node dict also has it. Okay, deleting the one in this node, and if node.next.freak is not equal to node.freak plus 1, then I need to make a new one. And this is fine for like the tail as well, because tail is gonna have a none freak. Okay, node.next.dig of key equals val. So what I'm doing here is setting the yeah, so I'm adding it to the dictionary with the freak plus 1. And then just return red, so I need to return it. Okay. So I think this is fairly reasonable. Now let's do the next function, which is put. So now that I have this written now, I think it's kind of similar. So if key is not in self.dict, then I need to like, okay, so if self.head.next.freak is not equal to 1, then I need to add at the head like a 1 node. Add after self.head 1. And then, okay, so I'm adding it behind the head. And now I know that the node is always going to have a frequency of 1, so I can just, okay, so self.dict of basically key is going to be equal to self.head to next. Self.head.next of .dict of key is going to be equal to val, right? Okay, so I'm adding it into this one. And then, okay, and then self.size. Oh yeah, that's what I was missing here. Okay, self.size plus equals 1. Otherwise, if it's in self.dict, then it's a bit harder. I have to basically, so it's going to be similar to the get in this case. Let me see how it's different, right? So I'm getting the node. That's the same. I don't need to return anything. So let's get it out of the self.dict. So this is the node. I don't need to return anything. Let me just delete it. Same with this, I think, right? If node.next.freak is not equal to node.freak plus 1, I need to add after, and then node.next, and this one's gonna be like val. Wait,
Yeah,
where did this val come from here? It should be red. But yeah, this should be val, right? Is that right?
yeah.
Okay. So node.next.dict of key is val. I don't want to return anything. And the size isn't updated, right? And then if self.size greater than self.cap, what I need to do is I need to get rid of the thing on the left. So the thing on the left is the like of head.next to the thing with the smallest frequency. I'm right now I'm just arbitrarily popping any of the keys. So let's just do okay. So rem node is going to be equal to self.head.next. And then if I'm going to get rid of a key value pair. So let's just do. Is there a way to like just pop something out of the dictionary? Is it like I know dot pop? I don't think that works.
Let me check. So
I can just do this. I can do del rem node of like rem node dot keys
0.
of
Yeah.
0, right? Okay. And okay, so if not rem node, okay, this should be dot dict. This should be dot dict, right? Yeah, so if not rem node dot dict, that means it's empty, right? So I need to get rid of this node now. So let me just get rid of it. Let's have a function here for getting rid of nodes. So let's just do self.rem. Oh, have I been updating the dictionary, like the main dictionary properly this whole time?
To be fair, I'm kind of confused because there's
Really?
so many dicks everywhere.
I probably should have named like the LFU node dict differently, huh?
Yeah,
Probably.
maybe.
Okay. If this doesn't work, it doesn't work. But I'm too deep now to like stop. So like let me just see if this works or not. But I do want to check if I was updating the main dict properly or not. So this node gets right. Node.next.dict key goes red. Yeah, I do need to do this. So self.dict of key is now equal to node.next. And then put here self.dict key goes self.head.next. So I think this is right. I don't think I do it here though. Node.next.freq is not equal to node.freq plus 1. I add after. And then self.dict of the key equals node.next. Okay, so let's just self.rem node. And let me del. Okay, sorry, I'm back. If not rem node.dict, I'm gonna remove this node, and I'm gonna delete Okay, yeah. So let me like say like removed key equals this. So I need to basically I need to also remove it from the main dictionary. So self.dict. Okay, if not remnode.dict, self.rem remnode. Is that good enough? I feel like that is all I have to do there. Okay, so I think that is like I feel like I covered all logic for the arbitrarily removing. But let me just look through all my functions again.
All right.
So hopefully let me also try to explain it so that it kind of makes sense because I know like my naming isn't that great. I think the main reason is because it's like so convoluted that like it's hard for me to like write and also have descriptive variable names. So
Yeah.
so essentially, add after makes sense, right? So add after takes a node, and then a new freak, and then essentially it's going to put a new node with this new frequency right after the node that you pass in. So this basically does that, right? Node.next.prev equals new node, new.next equals node.next, new.prev equals node.next equals new node. Okay, so that's what this one does.
Yeah.
Rem is just like removing the node, right? Self-explanatory.
Mm-hmm.
Okay, so get. First of all, I check if it's non-self.dict. Obviously, I return -1. So let me just describe this, right? So this whenever you see self.dict, what I'm doing is I'm trying to get it's like a mapping of the key to the actual LFU node in which that key lives.
Mm-hmm.
So basically, it's like so if you really want the value, you have to do self.dict of key dot dict of key.
Yeah. Okay, I see it.
Yeah. It's just I didn't want okay. So anyway, so node equals self.dict of key. I'm getting the node. So this is the node in which this key lives. Then ret equals node.dict of key. So as I said, you have to do self.dict twice.
Mm-hmm.
I mean .dict twice to get the actual value. So let's just call this value to make it clearer. Okay, then who keeps knocking my door, bro? Okay. Del node.dict of key. So I'm getting rid of it in this node. Oh yeah, I do need to check if this node is empty and then remove it if it is. So let me just do that here. So if not node.dict, let me just at the end though. Okay, anyway, so I'm deleting this key, so this dictionary could be empty, which is why I have to. If this dictionary is empty, I want to remove this node because it doesn't have anything in it anymore.
Mm-hmm.
If node.next, okay, hold up, dude. People are being hella loud. Okay, my bad. I'm back.
No problem.
Okay, so if the next node's frequency is not equal to my frequency plus 1, I need to add a new one. And then I'm basically putting my key value pair into the next one because I'm updating the frequency, right?
Mm-hmm.
So this node.next has a frequency plus 1, which is why I need to put it there. And then self.dict of key equals, so this is the mapping of the key to the node, remember? So I'm updating that. And then if my previous nodes dictionary size is empty, then I need to remove this node because I don't want any nodes with zero size in my doubly linked list because that would mess up my of1 removing the least frequently used thing. So removing that, then return val. Okay, and then for put, basically if key's not a dict, I need to make a new entry. So I need the frequency to be 1. So if the first node doesn't have frequency of 1, then I need to basically make a new node with frequency of 1. And then okay, and then self.dict of key equals self.head.next. So I'm putting mapping this is the key to the node mapping. I'm putting it to the new node I made. And then I'm within this node, I'm also doing a key to value mapping. And then I increment the size by 1 because it's a new one. But then otherwise, if it's already in the dictionary, then I need to get the node, delete it from the node, right? Am I doing this properly? Yeah. Okay. So if node.next.freak is not equal to node.freak plus 1, I need to add it.
Mm-hmm.
And then node.next.dict of key. That's the one I just made, right? Or the one that was already there, depending on whether I just made it or not.
Yeah.
I'm adding this in there, and then I'm updating the key to node mapping here. Okay.
Yeah.
And then I'm doing the size check. So if the size is greater than the capacity, then I need to basically then the node that I'm removing from is always going to be the one next ahead because that's the one with the lowest value. So this is rem node is going to be the one I'm removing from, and I'm picking like some random key to remove because I'm not doing like any LRU stuff here. .dig key is 0. And then basically I'm going to delete. You know what? This might actually be slow because this is O of n, where n is the number of keys, right?
Are you sure it just I thought it did like an iterator and you could just like take the first element. I'm not sure actually.
But does this turn into a list when I index like this, or is this still an iterator?
Maybe it breaks, I'm not sure actually.
Okay, let's just assume it's an iterator, so it's O of 1. Okay, let's assume it is. Okay, so I'm gonna delete it from the remnode.dig, right? And then I need to delete, what is this? Delete self.dig remove key. Yeah, because I'm getting rid of this entry. And then if this node doesn't have anything in its dictionary anymore, I need to remove the node and then decrement the size.
So why are you removing the key from the node? Okay, because don't you have to check if it's empty before deleting the node from the parent dictionary? Like this line.
This line? Well, this is the key, right? This is like the... Yeah, so okay, so this is like the key that I'm actually removing.
Okay, yeah, I see it.
So it's always gone. So I'm getting rid of the I want to rename this to like key to node or something. That'll be a lot clearer, I feel like. Right, because this is basically key to node mapping, and the node.dix is the key to value mapping.
Yeah.
Should I just rename that really quick?
Sure, man. If there's a
let's see if it runs first, and then I'll debug it, and then I'll rename it. How about that? Because I'm not really sure this is gonna run. It's probably not.
Sounds good.
Do you have a test case I can use here?
Yeah. Give me 1 second. I have the same good old Java. I'm gonna put it at the end. So this, and I'm just gonna remove all this extra stuff. Uh-oh, did something happen? Are you still there, Bunny? No.
Yeah, I am. Hello?
Okay. Yeah, okay. I thought I was lagging out.
No, you're good. I can hear you.
Do you see the example at the bottom of the repo?
Yeah, let me get this here. Let me just put it up here so I can see my code.
Okay.
Oh, that was quick. Oh, did you control F?
No, we just did it like same time.
Oh, the insert. Okay, that's cool. Okay, LFU object has no dick. Oh, because I started renaming it. Change this back. Okay, none object has no attribute freak. So self.head.next is none apparently. 62 input.
Yeah, I think this is where the fun begins, because one thing I want to point out to like everyone is like you probably should start testing as early as possible. So like let's say you finish writing one function or one small building block, you should like already start testing, because now we're gonna reach the end, and if there's bugs and like building blocks of our class that ends up breaking more stuff, then we're gonna have a real hard time debugging, and it's gonna cost a lot of time. But the earlier we start debugging, the better off we are, and the more confidence we can have in our code. Sorry, can go.
I mean, but my question is like, do they let you debug? Like in some of my interviews, they don't even let you run the code, which is like why I was just trying to do it in my head.
Yeah, I think that's fair. Like in my experience, like either it was on a piece of paper and you like just ran it like in your head, but in those cases, I think it's more simpler than like a super complex LFU cache. I don't think they would ask you to do an LFU cache without being able to run it. I don't think it's reasonable.
Okay.
But like
Yeah, I
if
probably should have just been running tests. Like I don't know. That's like my mindset is that I don't get to run it for some reason. So like
okay, okay.
I end up just not like testing it while I'm running. But I guess I should clarify that right in the beginning.
Yeah, I mean if you have the opportunity to do it, you should do it. But if you can't, well, that's another ballpark.
Okay. Well, okay, let me just give it a shot debugging this right now. So 62. So apparently self.head on X is none. Is in my initializer? Yeah, it is. Thank God it's here.
Okay, yeah.
It keys yeah, so you can't do this. I guess it is an iterator or like some like oh no, it's a dig keys object.
Try
What I
using
can
the
do instead
next function. You know the
oh
next to
yeah,
get
you're
the
right, yeah.
first element of a
Yeah,
iterator.
let's try this. Or is it like next
It's like
parentheses?
you wrap it, yeah.
Yeah. Okay.
No,
Oh, it's not an iterator.
you can
Okay.
probably convert it into an iterator, but yeah,
Let's just do this.
yeah.
I can like break after the first one, right?
Yeah.
Okay, this should get some random one. This should be old. Okay, let's see what it prints, right?
Mhm.
So I'm just gonna print out when it gets
Mhm.
print val print -1, right? Do you have the intended output? Oh, this is gonna be wrong because it's popping the wrong ones.
So the
Let me just draw that.
output is 1, -1, 3, -1, 3, 4. So it's just
The
the
reason is that I'm popping the order out wrong, I think, but it looks like
yeah.
it's kind of right.
Yeah, I think so. I think so too.
Like, let me just talk over like what I would do if I want to. So essentially, what I need to do is that like right now my LFU node is like a dictionary.
Yeah.
I need to replace this dictionary with the LRU cache, and then it's like it works, right?
Pretty
Because like
much.
it just modularized, like because what I need to do this to do is exactly what LRU cache does. So
Mm-hmm.
and then like whenever it's just when I add to the dict, I'll use the put, and then when I remove from the dict, I'll use the yeah. So I think that would work if I just plug this in, but it would take some time.
Yeah, pretty
So
much.
this would have like a self dot like cache or something, and then I'd have like a LRU cache and stuff.
Mm-hmm.
Should I just do that, or are we out of time?
I think we're out of time.
Okay.
I mean, we could technically do it for like laws if you're like super motivated to do it and you want to finish it and you think you can. I don't see why not, but in theory we would be done. But I'm not gonna stop you. Yeah, it's so beautiful to see,
Sure,
man.
I'm really motivated to do more typing. Like this has been like 200 lines, like 150.
Yeah, to be fair, it's really impressive to like just pull this off like you did. Like just all this complex logic with like nested dictionaries. I was just listening to you. I was like, oh my god, if it works, man, I won't believe it. But it
It's
seems like it does. Yeah.
yeah, I've just done so much stuff with like doubly linked list. I feel like it just but yeah, this is like really tough problem. Like
Mhm.
is this like so I know that instead of using LRU cache, you can also just use like an ordered dict here. But I feel like that's kind of cheating because
Yeah.
ordered dict is like or like I don't know what it's called, but there's some dictionary that's basically that LRU cache that you can use here as well.
Yeah, I have an example actually of that. I can show it
Okay.
on stream. But yeah, you basically just call the move to end function and it's gonna like handle the doubly linked list for you. And then you can say like pop the first item in the underlying doubly linked list and basically
Yeah,
does
yeah.
all the job for you. I'm not sure if it's a good idea to pull this one out in an interview because it's just like a cheese basically.
I mean, but like, do you feel like they'd expect you to like layer an LRU cache like here in an interview. Like I feel like it's unreasonable, right? It's like in an hour interview.
Doing LFU, yeah, it's definitely like absolving just because you were the guest today. But
I mean, do
yeah,
you feel do you feel like they'd ask this question though? Like this is
okay, so
like I kind of had the idea as soon as I heard the question, but like the implementation is just so long, and like you have to keep track of so much stuff.
so I found a question in daily coding problems, and they say like Google asks it. I don't know if it's true, but I think like if they do ask it, it's probably like they expect most people to like fail, but they want to like test your limits and like see who gets the furthest in the problem. Maybe something like that, because there are some types of problem that is like super hard, and they want to see how you react to such problems, I guess. So it's
Hmm.
basically see like people that panic when they don't know what they're doing, and see like how you react under pressure, I guess. So there's some purpose to like asking super hard questions like that. And it's basically like,
Hmm.
I think like the reaction you had was like perfect. I was like, okay, I'm gonna just ignore the part that has to handle with like the recency of the data you
Yeah,
need to remove. And I think that was like a perfect reaction. Okay, like let's reduce the problem down to something I can handle, then work on top of it. I think that's like the perfect reaction to have, and like try to ask as many questions as you can. But yeah,
yeah, yeah.
I don't think the intention is like to finish it,
Okay, cool. Yeah, sounds good.
just like Lawrence says. He knows.
Lawrence is watching me.
Yeah, of
Damn.
course, man. He's been waiting all
I
week.
haven't been in your stream, so
Aw. Yeah, Lawrence
okay.
is already always there, proudly supporting the stream. Thank you, Lawrence. So I'm gonna show my implementation of the LFU cache real quick, and it was like super similar. I feel like to like what you were getting to. Like
Hmm.
instead of using a dictionary, like you said, it was just another nested doubly linked list. And like for me, like I extracted the doubly linked list to another class, so I could like isolate all the logic for like removing, popping, and like refreshing values, like inserting. So I think like the cache logic could be separated from the linked list logic. So I think that was a good way to like separate the different concerns, I guess.
I guess that makes sense. It's kind of like hard for me to modularize stuff in my head during like a time constraint situation.
Mm-hmm.
It's like for me, it's easier to just like simulate what it does in my head and write out line by line. I feel like I kind of struggle with modularizing because like it kind of takes time to like split stuff up, right? And then
Yeah,
like
for
you
sure.
also have to code it and everything. So
Yeah, there's been like occurrences like I spend a lot of time like refactoring, and like my time is running out by the end of the interview. But I think like even like if it costs you some time and maybe like you don't finish everything you wanted to, it's still good and it leaves a good impression, I think. Like okay, let me like
Mhm.
refactor a bit, and like in the best case you manage to finish everything anyways. But I think like for like complicated questions like this, it's like an investment, because if you like you modularize and you test early, like you have less chances of running into bugs, while if you like just do it like all in one go, if it works then
Mhm.
perfect, you're like save some time on like testing and everything. But it's like in real life, like if you save time on testing, like you gain some technological depth. So if you manage to keep it reasonable for like an hour of the interview, then it's fine. But like it shows like good work habits, I guess, or how you code.
Yeah, yeah. I need to work on like coding style for like actual work. I feel like I don't know. I feel like my coding style is just like pure algo style, so it's not very modularized or anything. So
Yeah,
like for these kinds of questions, like my code ends up being it does look pretty messy and everything. So I think I should work on that.
yeah, I think it's fair. Well, after like being in code review a few times, I don't think it's a problem for that long. Like you have to adapt to the like how people code in a company, I guess, anyway. So it can vary.
Hmm.
Like some places don't even
Okay.
care that much. It's like when you work with
Yeah.
scientists that just use one-letter variables for everything, it can get messy. Sometimes you have to be the one that like show the right way.
Right. Yeah.
So I basically had this pretty much the same thing as you. I had like a parent dictionary that was like a dictionary of doubly linked lists, and like for that dictionary the key was like the frequency, and like the doubly linked list was like ordered according to the recency, and I had like a field here that indicated what was the minimum frequency, so I could easily remove in O of one time because I always knew which doubly linked list to remove from. And basically how to handle which is the minimum frequency. Well, when you add a new field, you always know that the minimum frequency is 1 because it's a new field, so it's never been used before. And when you update the cache, well, you check when you remove from the old doubly linked list. Well, if the old doubly linked list was the one that belonged to the minimum frequency and it was empty, well, you knew that the new minimum frequency just increased to like the current one. So that's a trick.
Wait, so how do you, like, let's say you had a minimum frequency of 1 or something, and then you got rid of that one. How do you get the next minimum frequency?
Well, since you're removing from that one, you know that you're taking what was from the minimum frequency of 1 and adding it to the frequency of 2. So it's always going to be 1 over that one. Right?
Well, what if you have like two keys, right? Say key 1 and key 2.
Yeah.
And they're both at frequency 1, and then you keep doing stuff to 2, so the frequency goes to like 6 or something.
Yeah.
And then you like ended up removing 1. Is that possible?
Yeah, it's possible. Well, removing
then it'll be 6, right? The next min. Or maybe that's impossible because you wouldn't have to remove that one.
Yeah, the size
because
doesn't change.
Unless the size increases, yeah.
And the only case where the size increases is when you insert, and when you insert, the new frequency is always 1, right?
Okay. Oh yeah, that's true. So then, yeah, you're right. Okay. Oh, that would have been
Actually,
easier.
wait, that's not true because the new frequency is 1, but you have to remove, like, let's say you have a capacity of like 1, and like you have one field that has like that is used like 6 times, but you have to remove that field that was used 6 times. But you can just rely on that field min frequency to keep track. So each time you update it, you check if the old one is empty, and then the min frequency follows. So it's like that chunk right here. No, this is deletion, it's here. So node frequency equals, so if the current node is the same as the minimum frequency and the old frequency is now empty, then you increment, and it works.
I feel like if I came up with that like insight, I could have avoided like some of the double linked list manipulation stuff I was doing, because I was thinking like you'd have to actually. Okay, I think I kind of get it. Maybe I'll like redo this problem later or something. Like figure out a better way to do it.
Yeah, maybe it's possible with just what I was trying at the start was like a linked list of linked list. So something similar with what you're doing, but instead of dictionary, it was like another linked list. I think it can work.
That's basically what I was gonna do, right? Like I was gonna have a linked list. Each node has an LRU cache, which is basically another linked list. So
yeah. So maybe there's many ways to do it, but whatever you do, it gets messy real fast. So just gotta do like small building blocks and get as far as you can, and not like maybe like loosen some constraints like Bunny did and say like, okay, I'm gonna do like a sub problem, and if I manage to do it in time, then I try to build upon it. I think that's a winning strategy.
Yeah.
Yeah.
All right.
So we'll end this here. I hope everybody had a good time. I hope, Bunny, did you have a good time?
Yeah, it was good. Next time, ask me algo question.
Yeah, for sure. You want to flex, don't you? I understand, man.
No, it just like really drained my brain, bro. Like writing all this code.
No, I understand. Like I was looking at you, I was like, okay,
Yeah, but it was cool though.
yeah. Do you think like it's a good exercise? Like even though you have like a bunch of experience, do you think like it still teaches you something? Do you think like it's a useful exercise at all, or do you have a contrary opinion?
I think that mocks like in general are really helpful because for me it's a bit harder to think when I have to talk out loud. But then during interviews you have to talk out loud. So I feel like even just having someone be there if they don't say anything kind of forces you to explain yourself, which is helpful. So that's like the helpful part for me, I feel like.
Yeah, makes sense. Huh. Oh, good to know. Well, I'm glad you enjoyed it. I really did. I got lost at some point, like in this dictionary stuff, but yeah, it was impressive, man. Thank you for being